Okay, here's a question for you. Who invented the idea that Earth floats in space? No, not Copernicus, not Galileo, not even the ancient Greeks you've actually heard of. Try a guy named Anaximander, writing in 610 BC, that's 2,600 years ago, in a Greek colony you've probably never visited, proposing ideas so radical that people are still catching up to them. We're about to journey back to one of the most remarkable moments in human intellectual history. This isn't just another dead philosopher lecture. This is about the birth of something extraordinary. The moment when human beings stopped explaining the world through gods and myths and started using reason. Started asking, what if we could figure this out ourselves? Anaximander stands at that threshold. He's one of history's most influential thinkers, yet somehow he remains overlooked, overshadowed by the philosophers who came after him. But here's what you need to understand. Without Anaximander, there's no Plato, no Aristotle, no Western philosophy as we know it, and the guy didn't even write a book that survived. We've got literally one sentence, one, that made it through 2,600 years. Everything else? Fragments, references, second-hand accounts. It's like trying to understand Einstein by reading tweets about him. But that one sentence? It's enough to blow your mind. And the ideas we can reconstruct from what later philosophers said about him? They're revolutionary. So let's do this properly. Let's give Anaximander his due. Because what he accomplished in that ancient Greek colony changed everything about how we understand reality. Let's start with the basics because context matters here. Anaximander was born around 610 BC in a place called Miletus. Now, if you're thinking ancient Greek philosophy equals Athens, you're about 150 years too early and in the wrong city. Miletus was a Greek colony on the coast of what's now Turkey, part of a region called Ionia. And this matters more than you might think. Miletus wasn't just any city, it was wealthy. We're talking serious prosperity from trade, sitting right at the crossroads between Eastern and Western civilizations. Ships came in from Egypt, Babylon, Persia, bringing not just goods but ideas. Mathematical knowledge from Babylon, astronomical observations from Egypt, different ways of thinking about the world. And here's what's crucial. When you're wealthy, you have something precious. Leisure time. Time to think. Time to wonder. Time to ask questions that don't immediately help you survive or make money. This is where philosophy is born. Not in poverty and struggle, but in prosperity and freedom. When people have enough to eat and time to spare, they start asking the big questions. What is everything made of? How did the world begin? What's our place in all this? Now, as you can see here, Anaximander is classified as a pre-Socratic thinker. This isn't just a chronological label, it's a fundamental philosophical category. The pre-Socratics were doing something humanity had never really done systematically before, seeking natural explanations for natural phenomena. Think about what this means. For thousands of years, when people wanted to know why it rained, the answer was, the gods are crying, or Zeus is angry. Why does the sun move across the sky? Apollo drives his chariot. Why earthquakes? Poseidon is shaking the earth. The pre-Socratics said, what if there's a natural explanation? What if we can understand this through observation and reason rather than mythology? This is revolutionary. This is the birth of science, philosophy, rational inquiry, all wrapped into one movement. And here's where it gets interesting. Anaximander didn't come from nowhere. He was the student of Thales, who's often called the first Western philosopher. Thales had already started this revolution by proposing that everything is fundamentally made of water. Not a god, not magic. Water. A natural substance you can observe and study. Now Thales was wrong about water being the fundamental substance. Spoiler alert. But he was brilliantly wrong. He was wrong in exactly the right way. He asked the right question. What is the fundamental nature of reality? He just picked the wrong answer. And this is where Anaximander comes in. He took his teacher's question and pushed it further. He thought, wait, Thales says everything is water, but I can see earth, air, fire. They don't look like water. They don't act like water. What if the fundamental reality is something more abstract? And with that thought, Anaximander made one of the most important conceptual leaps in human history. He proposed something called the apeiron, the boundless, the indefinite, the unlimited. not water, not any particular substance you can point to, something beyond ordinary perception, something transcendent, but we're getting ahead of ourselves. We'll dive deep into the apeiron in a moment. What I want you to appreciate here is the lineage. Anaximander studied under Thales. He learned from the master, but he didn't just accept what Thales taught him, he questioned it. He pushed it further, he improved upon it. And then Anaximander became a teacher himself. His student was Anaximenes, who would continue this tradition of rational inquiry, proposing air as the fundamental substance. Do you see what's happening here? This is the birth of a tradition, not just individual thinkers having random ideas, but a school, a community of inquiry where each generation builds on the last, questions the last, pushes further than the last. This is the Milesian school, and it's creating something unprecedented, a systematic rational approach to understanding reality. Thales asks, what is everything made of? Anaximander answers, something beyond our ordinary perception, the boundless. Anaximenes refines, air, something we can observe, but that takes many forms. Each one building, questioning, advancing. This is how knowledge grows. This is how philosophy works. So now we know who Anaximander was, a wealthy Greek colonist, a student of the first philosopher, a pre-Socratic revolutionary seeking natural explanations for natural phenomena. But who he was matters less than what he thought, and what he thought was extraordinary. In our next section, we're going to explore the historical context that made Anaximander's revolution possible, because ideas don't emerge in a vacuum. They emerge from specific times, specific places, specific conditions, and Miletus in 600 BC, that was the perfect storm for philosophical genius. But before we get to his ideas, and trust me, we're going to blow your mind with the apeiron, with his cosmology, with his evolutionary biology that predates Darwin by 2,400 years, we need to understand the world that produced him. Because here's the thing about revolutionary ideas, they don't just fall from the sky. They emerge from specific historical moments when conditions are just right for someone to think the unthinkable. So let's talk about Miletus in the 6th century BC, and why this particular time and place became the birthplace of Western philosophy. Alright, picture this. It's 600 BC. You're standing on the docks of Miletus, and ships are coming in from everywhere. Egyptian vessels loaded with grain and papyrus. Babylonian traders with astronomical charts, Persian merchants with spices and stories, Greek ships from colonies scattered across the Mediterranean. And it's not just goods moving through this port, it's ideas. Mathematical techniques from Babylon, star catalogs from Egypt, religious concepts from Persia, all colliding, mixing, creating this incredible intellectual ferment. This is the world that produced Anaximander. Now I need you to understand something crucial about the relationship between economics and ideas. Philosophy doesn't typically emerge from poverty and desperation. It emerges from prosperity and leisure. Why? Because philosophy is a luxury in the most profound sense. Not a luxury like a fancy car, a luxury like time. Time to think. Time to wonder. Time to ask questions that don't immediately put food on the table. Miletus had that luxury. The city was rich, trading hub, manufacturing center, financial powerhouse. And when you're that wealthy, something remarkable happens. You get a class of people who don't have to spend every waking hour just surviving. Think about it. If you're a subsistence farmer barely scraping by, you're not sitting around wondering, what is the fundamental nature of reality? You're wondering, will it rain this week so my crops don't die? Very different questions. But in Miletus, people had space to think. And not just individual space. They had institutional space, public forums, gathering places, a culture that valued intellectual discussion. This economic success fostered something unprecedented, intellectual freedom, the freedom to question, the freedom to speculate, the freedom to propose wild, radical ideas without immediately being shut down because you're supposed to be working. Now here's where it gets really interesting. The Milesian school, Thales, Anaximander, and Anaximenes, they pioneered something that seems obvious to us now but was absolutely revolutionary then. They sought material explanations rather than mythological ones. Let me be clear about what this means. For thousands of years, human beings, explained natural phenomena through stories about gods and supernatural forces. And these weren't just primitive superstitions, these were sophisticated, complex mythological systems that made sense of the world. Why does the sun rise and set? Because Helios drives his chariot across the sky. Why do we have seasons? because Persephone spends half the year in the underworld with Hades, and her mother Demeter grieves, making the earth barren. Why earthquakes? Poseidon, god of the sea and earth shaker, is angry. These explanations worked for people. They provided meaning, comfort, a sense of order. And then the Milesians come along and say, what if there's a natural explanation? What if we can understand these phenomena through observation, reason, and logic, rather than appealing to divine intervention? This is audacious. This is borderline heretical. This is saying, we can figure this out ourselves. We don't need the gods to explain the world to us. Do you understand how radical this is? This is the birth of rational inquiry. This is the moment when human beings claim the right and the ability to understand nature on its own terms. As you can see here on the slide, this was an age of awakening curiosity about the natural world. But that phrase doesn't quite capture the electricity of the moment. This was a time when people were starting to realize, wait, we can systematize knowledge. We can build on what others have discovered. We can create a body of understanding that grows over time. Before this, knowledge was mostly transmitted through tradition, through stories, through religious authority. You knew things because your elders told you, because the priests said so, because that's how it had always been done. But the Milesians were doing something different. They were saying, let's observe the world, let's reason about what we observe, let's test our ideas against reality, and let's build on each other's work. This is the birth of what we might call the scientific attitude, though they didn't have that word yet. This is the beginning of systematic inquiry, and here's what I want you to appreciate. These early attempts to systematize knowledge beyond religious traditions were hard, incredibly hard. Think about what they were trying to do. They were trying to explain the entire cosmos, the earth, the heavens, the weather, life itself, using only observation and reason. No laboratories, no telescopes, no microscopes, no mathematics beyond basic geometry, no accumulated body of scientific knowledge to draw on. They had to start from scratch. They had to invent the very methods of rational inquiry while simultaneously using those methods to understand the world. It's like trying to build an airplane while you're falling out of the sky, except worse, because at least with the airplane you know what you're trying to build. These guys didn't even know what rational explanation fully meant yet. They were inventing it as they went. And yet, and this is what's remarkable, they succeeded. Not in getting everything right. They got plenty wrong. But they succeeded in establishing a tradition of rational inquiry that continues to this day. Every time a scientist proposes a hypothesis and tests it against evidence, they're following in the footsteps of the Milesians. Every time a philosopher asks, what is the fundamental nature of reality, they're asking Thales' question. Every time we seek natural explanations for natural phenomena, we're honoring the revolution that began in Miletus 2,600 years ago. So that's the context. That's the world that produced Anaximander. A wealthy, cosmopolitan trading city, an intellectual climate that valued curiosity and questioning, a philosophical movement that dared to explain nature through reason rather than myth. Now, finally, we can talk about what Anaximander actually contributed to this revolution. And trust me, it's going to blow your mind. Okay, here we go. This is where it gets good. Look at this slide. 4 major areas of contribution: cosmology, geography, biology, metaphysics. Now, most philosophers, even great ones, make their mark in one area, maybe 2 if they're really ambitious. Anaximander revolutionized 4. Let me say that again. This one guy in one lifetime in 600 BC made groundbreaking contributions to cosmology, geography, biology, and metaphysics. That's not just impressive, that's almost incomprehensible. But here's what I want you to understand before we dive into each area. These contributions aren't isolated. They're all connected by a single powerful idea, that the world can be understood through rational principles, through observation and logical reasoning. Let's go through them one by one, and I want you to appreciate not just what he proposed, but how he thought. Anaximander developed revolutionary theories about the structure of the universe and Earth's place within it. Now, when I say revolutionary, I don't mean interesting or innovative. I mean he proposed ideas so radical that they weren't fully accepted for thousands of years. Here's his big cosmological claim. Earth floats freely in space, unsupported, held in place by being equidistant from all things. Let that sink in for a moment. In 600 BC, When everyone, and I mean everyone, believed Earth had to be resting on something solid, Anaximander says, no, it's just floating in space, not falling because there's nowhere to fall to. This is insane. This is brilliant. This is one of the most important ideas in the history of human thought. And of course, people thought he was crazy. Earth can't just float. It has to be resting on something. What's it resting on? Well, it's resting on a giant turtle. And what's the turtle standing on? Another turtle. And that turtle? Look, it's turtles all the way down, okay? Stop asking questions. But Anaximander saw the problem with this infinite regress. If Earth needs something to rest on, then that thing needs something to rest on, and so on forever. So he made this brilliant logical leap. What if Earth doesn't need to rest on anything? What if it's held in place by equilibrium? We'll dive deeper into his cosmological model in a moment, but I want you to appreciate how radical this thinking is. He's using logic to solve a problem that everyone else was solving with mythology or infinite turtles. Anaximander created the first known map of the world and pioneered cartography as a discipline. Now, this might not sound as sexy as floating Earth, but think about what a map is. A map is an abstract representation of physical reality. It's taking the three-dimensional world and representing it in two dimensions. It's selecting what information to include and what to leave out. It's creating a model of reality. This is sophisticated abstract thinking. This is saying, I can create a representation of the world that helps us understand and navigate it. And he didn't just draw a picture of what he could see. He tried to map the entire known world, all the lands that Greek traders had reached, all the seas they had sailed. He was trying to create a comprehensive picture of reality based on accumulated observations. This is systematic thinking. This is the scientific method in embryonic form. Okay, now we're getting to something that absolutely blows my mind. Anaximander proposed early evolutionary ideas about life's origins and human development. Let me be clear, Charles Darwin published On the Origin of Species in 1859. Anaximander was thinking about evolution in 600 BC, that's 2,400 years earlier. Now, he didn't have natural selection. He didn't have genetics. He didn't have the full modern theory. But here's what he did have. The insight that humans couldn't have always existed in their current form. His reasoning was beautifully simple. Human babies are helpless. They need years of care to survive. So if the first humans were born as helpless infants, they would have died. Therefore, early humans must have developed within other creatures, he thought fish-like animals, until they were mature enough to survive on their own. Do you see what he's doing here? He's using logical reasoning to deduce something about the past that he can't directly observe. He's saying, given what I know about human biology, the past must have been different from the present. This is evolutionary thinking. This is understanding that life forms change over time, and he's doing this in 600 BC. And finally, perhaps most importantly, Anaximander introduced the concept of the apeiron as the boundless, indefinite source of all things. This is his most profound contribution, and we're going to spend serious time on it in the next section. But here's the preview. Anaximander's teacher Thales said everything is fundamentally water, a specific observable substance. Anaximander said, no, the fundamental reality is something beyond specific substances, something boundless, something indefinite, something we can't directly perceive but must infer through reason. This is the birth of metaphysics, the study of reality beyond the physical. This is abstract philosophical thinking at its highest level. He's not just asking what is the world made of. He's asking what is the fundamental nature of reality itself? What lies beneath all the appearances? And his answer, the apeiron, the boundless, is so sophisticated, so philosophically rich, that people are still writing papers about it today. The unity of his thought now. Here's what I want you to see. These four contributions aren't random. They're all expressions of the same fundamental approach to understanding reality. In cosmology, he uses logical reasoning to deduce that Earth must float freely. In geography, he creates abstract representations to systematize knowledge. In biology, he uses logical inference to understand the past. In metaphysics, he proposes abstract principles underlying physical reality. This is a unified philosophical vision. This is someone who has grasped that reality can be understood through reason, observation, and logical inference. Someone who isn't satisfied with surface appearances but wants to understand the deep structure of things. And he's doing all of this, all of it, in 600 BC, at the very dawn of Western philosophy. So now that we've surveyed the landscape of his contributions, let's dive deep into each one. Let's really understand what he proposed and why it matters. And we're going to start with the big one, the concept that defines his entire philosophical project. We're going to talk about the apeiron. Because once you understand the apeiron, once you really get what Anaximander was proposing, everything else falls into place. His cosmology, his geography, his biology, they all flow from this one profound insight about the fundamental nature of reality. So let's go there. Let's explore the boundless, the indefinite, the unlimited. Let's talk about the apeiron. The apeiron is one of the most important concepts in the history of philosophy, and it's also one of the most difficult to grasp. Because Anaximander is asking us to think about something that, by definition, we cannot directly perceive. He's asking us to use pure reason to understand the foundation of reality itself. And what he proposes is going to challenge everything you think you know about how the world works. Alright, deep breath. We're about to do some serious philosophy here. The apeiron, the boundless, the indefinite, the unlimited. This is Anaximander's answer to what philosophers call the first principle, the fundamental reality from which everything else comes. And I need to tell you right up front, this is hard. Not because the concept is poorly thought out, but because Anaximander is asking us to think about something that transcends ordinary experience. He's asking us to use pure reason to grasp something we can never directly perceive. So let's take our time with this. Let's really understand what he's proposing. Remember, Anaximander's teacher Thales had already asked the fundamental question, what is everything made of? What's the basic substance of reality? And Thales answered, water. Now, this was brilliant for its time. Thales was saying, look, forget the gods. Forget mythology. There's a natural substance that underlies everything, something we can observe and study. And if you think about it, water is a pretty good candidate. It takes multiple forms, liquid, solid ice, gaseous steam. It's essential for life. It's everywhere. You can see how Thales got there. But Anaximander saw a problem, a deep, fundamental problem. If everything is water, then what about fire? Fire and water are opposites. Fire destroys water. Water extinguishes fire. How can fire be a form of water when it's water's opposite? And what about earth? What about air? These don't seem like forms of water either. So Anaximander thought, my teacher asked the right question, but his answer is too specific, too limited. The fundamental reality can't be any particular substance because then we can't explain how its opposite comes to exist. And this is where Anaximander makes his brilliant leap. He says, what if the fundamental reality is something beyond all particular substances? Something that's not water, not fire, not earth, not air, but something that can give rise to all of them? And that's the apeiron. Now look at the slide. 3 aspects of the apeiron: transcendent reality, material generation, cosmic justice. Let's unpack each one carefully. The apeiron is boundless. It has no limits, no boundaries, no definite characteristics. It's indefinite. You can't define it by pointing to specific qualities like wet, or hot, or solid. It's unlimited. It extends infinitely in all directions, in all ways. Now here's what's philosophically radical about this. Anaximander is proposing that the fundamental reality is something we cannot directly perceive. Think about how wild this is. Every previous explanation of reality had been based on things you could see, touch, experience: water, earth, the gods appearing in human form. But Anaximander says, no, the deepest reality is beyond perception. We can only grasp it through reason. This is the birth of metaphysics, the study of reality beyond the physical. This is abstract philosophical thinking at its most sophisticated. He's saying, don't trust your senses to tell you about fundamental reality. Use your mind. Use logic. Infer what must be true even if you can't see it. This is a complete revolution in human thought. So if the apeiron is boundless and indefinite, how does it create the specific, definite things we see around us? Anaximander's answer: through the separation of opposites. The apeiron contains all opposites in potential, hot and cold, wet and dry, light and dark, but they're not yet separated. They're in a kind of primordial unity. Then, through some process, and Anaximander isn't entirely clear on the mechanism, which is fair enough for 600 BC, these opposites begin to separate out from the boundless. Hot separates from cold and you get fire and ice. Wet separates from dry and you get water and earth. And these basic opposites combine in various ways to create everything we see in the world. Do you see the elegance of this? The apeiron doesn't become the world. It generates the world by allowing opposites to emerge and separate. It's like, imagine a perfectly still, infinite ocean. Then ripples begin to form. Those ripples are the opposites separating out. The ocean itself doesn't change. It remains boundless. But the ripples create all the diversity we see. Now I want you to notice something important here. Anaximander is thinking in terms of processes, not static things. Reality isn't just a collection of objects. It's a dynamic process of generation and return. This is sophisticated philosophical thinking. This is understanding that the world is fundamentally active, not passive. And now we come to the most profound aspect of the apeiron, and the one fragment of Anaximander's actual words that survived. Here's what he wrote, and this is the only sentence we have in his own words. The things that are perish into the things from which they come to be, according to necessity, for they pay penalty and retribution to each other for their injustice according to the assessment of time. Now that's a translation from ancient Greek, and it's a bit poetic, but here's what he's saying. Everything that comes into existence is, in a sense, committing an injustice by separating from the apeiron, by becoming definite, limited, particular, and everything must eventually pay the penalty for that injustice by returning to the boundless. This is cosmic justice. This is the idea that reality itself has a kind of moral structure, not in the sense of human morality, but in the sense of balance, equilibrium, fairness. Hot and cold separate from the apeiron. But if hot becomes too dominant, cold must assert itself to restore balance. If summer goes on too long, winter must come. If day extends, night must follow. The apeiron maintains equilibrium in nature. It's the source from which all things emerge, and it's the destination to which all things return. It ensures that no opposite can permanently dominate, that balance is always restored. This is why the apeiron must be boundless, because if it were limited, it could run out. If it were definite, it would favor one opposite over another. Only something truly infinite and indefinite can be the impartial source and destination of all things. Okay, let me tell you why this is one of the most important ideas in the history of philosophy. First, Anaximander has moved philosophy from the concrete to the abstract, from what we can see to what we can reason about. This opens up entirely new domains of philosophical inquiry. Second, he's introduced the idea that reality has layers. There's the world of appearances, the things we see and touch. And then there's the deeper reality underlying those appearances. This distinction will dominate Western philosophy for the next 2,600 years. Third, he's proposed that the fundamental reality is characterized by unity and balance rather than conflict and chaos. The apeiron maintains cosmic justice. This is a profoundly optimistic vision of reality. And fourth, perhaps most importantly, he's shown that pure reason can take us beyond the limits of perception, that we can think our way to truths about reality that we could never observe directly. This is the foundation of all metaphysics. This is the beginning of philosophy as we know it. And remember, this guy's teacher thought everything was water. In one generation, we've gone from "it's all water" to "the fundamental reality is an infinite, indefinite, boundless source beyond all perception that maintains cosmic justice through the equilibrium of opposites." That's quite a leap. Now you might be thinking, okay, this is all very abstract and philosophical. But what does it mean practically? How does this help us understand the actual world we live in? Great question. And that's exactly what we're going to explore next. Because Anaximander didn't just propose an abstract metaphysical principle and leave it at that. He used the concept of the apeiron to build an entire cosmology, a complete theory of how the universe is structured. And that cosmology is going to blow your mind. All right, now we get to see Anaximander's genius in action. We're going to watch him use his abstract principle, the apeiron, to deduce concrete facts about the structure of the universe. And what he comes up with is so radical, so counterintuitive, so brilliantly reasoned that it took humanity over 2,000 years to fully accept it. Look at this slide. Three key claims: unsupported Earth, cylindrical shape, equilibrium. Let's break down each one and understand not just what he claimed, but how he reasoned his way there. Here's Anaximander's claim. Earth floats freely in space, maintained by equal distances from all things. Now, I need you to understand how insane this sounded to his contemporaries. Every culture up to this point, Egyptian, Babylonian, Greek, believed Earth had to be resting on something solid. Because that's what our experience tells us, right? Things fall down unless they're supported. Drop a rock, it falls. So Earth must be resting on something. The Egyptians thought Earth was supported by pillars. Some Greeks thought it floated on water, Thales' view. The Hindus had the cosmic turtle. Everybody had something holding Earth up. And then Anaximander comes along and says, what if it's not resting on anything? What if it's just floating in space? People must have looked at him like he'd lost his mind. But Anaximander, things fall. If Earth isn't resting on something, it'll fall. And here's his brilliant response. Fall where? Fall in which direction? Think about this carefully. If Earth is at the center of everything, equidistant from all points in the cosmos, then there's no direction for it to fall in. Down? Down relative to what? If you're at the center, every direction is equally down, or equally up. The concepts lose meaning. So Earth doesn't need support because there's nowhere for it to fall to. It's held in place by perfect equilibrium, by being equally distant from everything. Do you see what he's done here? He's used pure logic to solve a problem that everyone else was solving with mythology or physical supports. He's saying, given the symmetry of the cosmos, given that Earth is at the center, it must float freely. Not because I can see it floating, I can't, but because reason demands it. This is using abstract reasoning to deduce facts about physical reality. This is theoretical physics 2,000 years before physics existed. Now Anaximander also proposed that Earth has a specific shape. It resembles a column drum with a depth 1/3 of its width. So not a sphere, a cylinder, like a short, squat drum. Now, he's wrong about this. Earth is roughly spherical, as the later Greeks figured out. But here's the thing. He's wrong in an interesting way. He's wrong while doing something right. What's he doing right? He's proposing a specific geometric model of Earth's shape. He's using mathematics and geometry to describe physical reality. Why a cylinder? Probably because it fits with his idea of equilibrium. A cylinder has symmetry. It looks the same from all sides around its circumference. That symmetry supports the idea that Earth wouldn't favor falling in any particular direction. The ratio, depth 1/3 of width, suggests he was trying to match this to observations. Maybe the visible horizon suggested a certain curvature. Maybe he was trying to account for how far you could see. The point is, he's not just making stuff up. He's proposing a testable geometric model based on reasoning and observation. He's doing science, even if his specific answer is wrong, and that's what matters. Not that he got the exact shape right, but that he understood you should propose specific geometric models of physical reality. And now we see how everything connects back to the apeiron. Why does Earth float freely? Because of equilibrium. Why equilibrium? Because the apeiron maintains balance in all things. The cosmos is structured by the same principle of justice and balance that governs the separation and return of opposites. Earth sits at the center in perfect equilibrium because that's where the cosmic balance places it. Imagine Anaximander's universe. At the center, Earth, a cylindrical drum floating freely in space. Around it, the celestial bodies moving in perfect circles. Everything balanced, everything in its proper place, everything governed by rational principles of equilibrium and justice. No chaos, no arbitrary divine whims, just rational geometric order. This is a cosmos in the true Greek sense, an ordered, rational, beautiful universe. Not a random collection of stuff, but a structured whole governed by intelligible principles. Now let me tell you why this matters so profoundly. First, Anaximander has proposed that Earth doesn't need physical support. This idea, that objects can be held in place by forces rather than physical contact, won't be fully developed until Newton's theory of gravity 2,300 years later. He's anticipating one of the most important ideas in physics, that invisible forces can act at a distance. Second, he's using geometric reasoning to model physical reality. This becomes the foundation of all mathematical physics. When Galileo says the book of nature is written in mathematics, he's following Anaximander's lead. Third, he's proposed a testable model. You could, in principle, verify or falsify his claims about Earth's shape and position. This is the scientific method in embryonic form. And fourth, most profoundly, he's shown that the universe is comprehensible, that human reason can grasp the structure of reality, that we're not at the mercy of incomprehensible divine forces, but living in a cosmos we can understand. This is empowering. This is saying, you, human being, with your capacity for reason, can understand how the universe works. Now, I don't want to oversell this. Anaximander got a lot wrong. Earth isn't cylindrical, it's spherical. Earth isn't at the center of the universe. It orbits the sun, which is one star among billions. The celestial bodies aren't wheels of fire encased in mist. They're planets, stars, galaxies. But here's what he got right, and this is what matters. He got right that you should use reason and observation to build models of reality. He got right that geometric and mathematical thinking can help us understand the cosmos. He got right that the universe operates according to rational principles, not arbitrary divine intervention. He got right that we should propose specific, testable theories rather than vague mythological stories. In other words, he got the method right, even when he got specific results wrong. And the method is what endures. The method is what makes science possible. The method is what allows later thinkers to correct his errors and build better models. I want you to appreciate the sheer intellectual courage this required. Anaximander is asking people to believe something that contradicts their direct experience. You feel like you're standing on solid ground. You feel like there's an absolute down. You feel like things need support or they fall. And he's saying, your feelings are misleading you. Trust reason instead. Trust logic. The universe is not how it appears to your senses. This is the birth of theoretical thinking. This is the beginning of the idea that reality has a structure that transcends immediate appearance, that we can use our minds to grasp truths that our senses cannot reveal. Every time a physicist proposes that space is curved, or that time is relative, or that particles can be in two places at once, every time we're asked to believe something counterintuitive based on theoretical reasoning, we're following in Anaximander's footsteps. He showed us that it's possible, that human reason can take us beyond the obvious, that we can think our way to truths about reality that seem impossible at first. Now, Anaximander didn't stop with Earth's position and shape. He built an entire model of the celestial bodies, the sun, moon, and stars. And that model is even more creative, even more imaginative than his theory of Earth. So let's keep going. Let's see what he proposed about the heavens themselves. Because if you thought floating Earth was wild, wait until you hear his theory of the sun and stars. He proposes that the celestial bodies are actually wheels of fire encased in mist, with holes that let the fire shine through. And the size of these wheels? The sun is 28 times the size of Earth. The moon is 19 times. How did he calculate this? Why those specific numbers? And what does this tell us about his method? Let's find out. Alright, so we've got Earth floating freely in space, already pretty wild for 600 BC, but now Anaximander has to explain everything else. The sun, the moon, the stars. And what he comes up with is, well, it's creative. It's imaginative. And it reveals something fascinating about how he thinks. Look at this slide. Anaximander imagined the sun, moon, and stars as rings of fire encased in mist, with openings that allow the fire to shine through. Wheels of fire, wrapped in fog, with holes. Now your first reaction might be, that's ridiculous, that's obviously wrong. And yes, it's wrong. We know the sun is a massive ball of fusing hydrogen. The moon is a rocky satellite reflecting sunlight. The stars are distant suns. But before we dismiss this as ancient nonsense, let's actually think about what Anaximander is doing here, because there's serious philosophical work happening. Anaximander proposes that the sun is a wheel of fire, 28 times the size of Earth. Now, first question, why a wheel? Why not just a ball of fire? Think about what Anaximander can observe. The sun moves across the sky in a regular path. Every day, same motion. Circular motion. Predictable. If the sun is moving in a circle, maybe it is a circle. Maybe what we're seeing is part of a larger circular structure, a wheel, that rotates around Earth. And the fire, well, the sun is clearly hot. It gives off heat and light. Fire is the obvious explanation for that in 600 BC. But here's the clever part. If the sun were just a ball of fire moving through the air, wouldn't it set things on fire as it passed? Wouldn't it burn out? So Anaximander proposes, the fire is contained within something, encased in mist or vapor, and we only see the fire through an opening in that casing. Do you see what he's doing? He's trying to solve real problems. He's not just making stuff up. He's proposing a mechanism that explains both what we observe, light and heat, and what we don't observe, everything catching fire. Now, why 28 times the size of Earth? That's oddly specific. Here's what's remarkable. Anaximander is trying to calculate the size of celestial bodies. He's not just saying the sun is big. He's proposing a specific ratio. How did he arrive at 28? We don't know for certain, but scholars have theories. It might be based on observations of the sun's apparent size and estimates of its distance. If you assume the sun is a certain distance away, and you measure its apparent size in the sky, you can calculate its actual size. Or it might be based on numerical patterns he observed. The ancient Greeks loved mathematical ratios and proportions. 28 has interesting mathematical properties. It's a perfect number, meaning it equals the sum of its divisors. But here's what matters. He's using mathematics to describe the cosmos. He's proposing that the universe has a mathematical structure that we can discover and describe. This is huge. This is the beginning of mathematical astronomy. Similarly, the moon is a wheel of fire, 19 times the size of Earth. Now the moon is obviously dimmer than the sun. How does Anaximander explain this? Same mechanism, it's a wheel of fire, but with a smaller opening. Less fire visible, less light produced. And notice, he's using the same explanatory principle for both sun and moon. This is theoretical elegance. One mechanism explains multiple phenomena. This is good scientific thinking. The different sizes, 28 for the sun, 19 for the moon, probably reflect his attempts to calculate based on their apparent sizes and estimated distances. And the stars? Compressed fire visible through holes in celestial wheels. Now this is fascinating. The stars are clearly dimmer and smaller than the sun and moon. So Anaximander proposes they're the same kind of thing, fire visible through openings, but either the wheels are smaller or the openings are smaller, or both. Think about what he's doing here. He's proposing a unified theory of celestial phenomena. Sun, moon, stars, they're all the same basic thing, just varying in size and brightness. This is the scientific impulse. Find the simplest explanation that accounts for all the data. Don't multiply entities unnecessarily. Use one principle to explain everything you can. And all these wheels move in circular paths around Earth in cosmic harmony. Why circles? Because circles are perfect. They have no beginning or end. They represent eternal, unchanging motion. And remember the apeiron, the principle of balance and equilibrium. Circular motion maintains that balance. The celestial bodies don't fly off in random directions. They move in ordered, predictable paths. Imagine Anaximander's cosmos. At the center, cylindrical Earth, floating in equilibrium. Around it, great wheels of fire, the sun 28 times Earth's size, the moon 19 times, countless stars, all rotating in perfect circles, all governed by the same rational principles. It's beautiful. It's ordered. It's comprehensible. It's wrong. But it's wrong in exactly the right way. What he got right, even when he was wrong. Now let's be clear about what Anaximander got wrong. The sun isn't a wheel of fire. It's a sphere of fusing hydrogen. The moon isn't a wheel of fire. It's a rocky body reflecting sunlight. The stars aren't nearby wheels. They're distant suns, light years away. The celestial bodies don't orbit Earth. Earth and the other planets orbit the sun. But here's what he got right. He got right that you should try to calculate the sizes of celestial bodies, not just describe them vaguely. He got right that you should look for unified explanations. One principle explaining multiple phenomena. He got right that celestial motions are regular and predictable, governed by natural laws. He got right that you should propose specific, testable models rather than just saying the gods do it. In other words, he got the approach right, even when the specific content was wrong. And that's what makes him a pioneer. Not because he had all the answers, nobody in 600 BC could have all the answers, but because he asked the right questions and used the right methods. The imaginative leap. and I want you to appreciate the sheer imagination required here. Anaximander is trying to explain things he can never directly observe. He can't travel to the sun. He can't examine the stars up close. He has only what he can see from Earth's surface, and from that limited vantage point, he's constructing a model of the entire cosmos. That takes creativity. That takes the ability to think beyond what's immediately visible. I mean, wheels of fire encased in mist with holes. That's pretty creative. It's like cosmic Swiss cheese made of fire and fog. It's wrong, but it's interestingly wrong. It shows a mind trying to solve real problems with the tools available. And here's something to consider. Every scientific theory is, in some sense, a creative act of imagination. Einstein imagining riding on a beam of light. Heisenberg imagining that particles don't have definite positions. Darwin imagining the tree of life. Science isn't just about collecting data, it's about imagining explanations for that data. Creating models. Building theories. Anaximander is doing that. He's showing us that the human mind can construct models of reality that go beyond immediate observation. Here's what I want you to take away from this. When we study ancient philosophy and science, we're not studying it to learn the right answers. We obviously know more about the sun and stars than Anaximander did. We study it to understand how human beings learned to think about these questions, how we developed the methods that eventually led to correct answers. Anaximander's wheels of fire are wrong, but his approach, observe, reason, calculate, propose specific models, that's right. That's the method that eventually gives us Copernicus, Galileo, Newton, Einstein. Every time an astronomer calculates the size of a distant star, they're using the same basic approach Anaximander pioneered: observation plus mathematical reasoning. Every time a physicist proposes a model of something we can't directly observe, dark matter, black holes, the early universe, they're doing what Anaximander did, using reason and imagination to extend our understanding beyond the visible. Now, Anaximander's cosmology gets even more interesting. Because he doesn't just propose one universe with Earth at the center, he proposes infinite universes, infinite worlds, constantly being born and dying. And this idea, this concept of multiple worlds, is going to absolutely blow your mind. Okay? Okay? Hold on to your seats. We've talked about the apeiron, the boundless infinite source of all things. We've talked about Earth floating in space. We've talked about wheels of fire. But now, Anaximander proposes something that sounds like it came straight out of modern physics. He proposes that our universe, our entire cosmos, is just one of infinite possible worlds, multiple worlds, infinite universes, each one emerging from the apeiron, existing for a time, then returning to the boundless. In 600 BC, let me say that again. In 600 BC, Anaximander proposed what modern physicists call the multiverse, creation. Worlds constantly emerge from the boundless apeiron. Here's how it works in Anaximander's system. Remember the apeiron, infinite, boundless, containing all opposites in potential. From this boundless source, worlds constantly emerge. Not just our world, worlds, plural, infinite worlds. How? Through the same process that created our world, the separation of opposites. The apeiron is in constant motion. It's not static. And in different regions of this infinite boundless reality, opposites begin to separate. Hot from cold, wet from dry, light from dark. Each separation creates the conditions for a world to form, a cosmos, a structured reality. And this is happening constantly. Not just once at the beginning of time, but eternally. Always new worlds emerging from the apeiron. Do you see how radical this is? Most ancient cosmologies had one creation event. The gods made the world, and that's it. One world, one creation. But Anaximander says, no, creation is ongoing. The apeiron is constantly generating new worlds, infinite worlds, forever. Now, each of these worlds, once created, operates according to natural laws. The same kinds of principles we see in our world: equilibrium, balance, the interplay of opposites. Each world has its own structure, its own arrangement of elements, its own celestial bodies, its own duration. And here's what's important. These worlds aren't arbitrary or chaotic. They're ordered. They're governed by rational principles. Even though there are infinite worlds, each one is a cosmos, an ordered, intelligible reality. This is crucial. Anaximander isn't saying anything goes or chaos reigns. He's saying there are infinite ordered realities, each governed by natural law. This preserves the rationality of the universe while acknowledging its infinite creative potential. But, and this is key, no world lasts forever. Remember that fragment we discussed earlier? Things perish into the things from which they come to be. They pay penalty and retribution for their injustice. Each world, by separating from the apeiron, commits an injustice. It becomes definite, limited, particular. When the fundamental reality is infinite and boundless, and eventually that injustice must be corrected, the world must return to the apeiron. How does this happen? The opposites that separated to create the world gradually lose their separation. Hot and cold, wet and dry, they begin to merge back together. The structure breaks down. The cosmos dissolves, and the world returns to the boundless source from which it came. This is cosmic justice on the grandest scale imaginable. Not just individual things being born and dying, entire universes being born and dying. The apeiron gives birth to worlds, and the apeiron reclaims them. The cycle is eternal. And here's where it gets truly mind-blowing. When a world returns to the apeiron, that's not the end. The apeiron continues its eternal motion, and new worlds emerge. The cycle never stops. Creation, existence, destruction, rebirth, forever. Infinite worlds, emerging and dissolving, in an eternal cosmic dance. Do you understand what this means? Our universe, everything we can see, everything we know, is just one moment in an infinite process. One world among infinite worlds. One cosmic cycle among infinite cycles. We are not the center of everything. We are not the only reality. We are one expression of the infinite creative power of the apeiron. This is humbling. This is awe-inspiring. This is philosophy at its most profound. Now I need to tell you something that's going to sound crazy. Modern physics, cutting-edge, 21st century theoretical physics, has arrived at something remarkably similar to Anaximander's multiple worlds theory. In quantum mechanics, there's an interpretation called the many worlds interpretation. It proposes that every quantum event causes the universe to split into multiple versions, each representing a different possible outcome. In cosmology, there are theories of eternal inflation that propose our universe is just one bubble in an infinite foam of universes, each with potentially different physical laws. String theory suggests there might be 10,500 possible universes, each with different configurations of fundamental constants. Now, I'm not saying Anaximander somehow knew modern physics. He didn't. He couldn't have. But what I'm saying is this. When you think deeply about the nature of reality, when you follow reason wherever it leads, you sometimes arrive at similar conclusions across vast stretches of time. Anaximander, using pure philosophical reasoning, arrived at the idea that our universe might not be unique, that reality might be far vaster than what we can observe. And 2,600 years later, physicists using mathematics and observation are proposing similar ideas. That's the power of philosophical thinking. That's what happens when you take reason seriously and follow it to its conclusions. The philosophical implications. Now, let's think about what this multiple worlds theory means philosophically. First, it radically decenters humanity. We're not the center of the universe. We're not even in the only universe. We're one species, on one planet, in one world, among infinite worlds. This is humbling. This puts our concerns in perspective. Second, it suggests that reality is far more creative, far more abundant than we might have imagined. The apeiron doesn't create once and stop. It creates endlessly, infinitely. This is an optimistic vision. Reality is characterized by infinite creative potential. Third, it implies that existence is temporary, but renewal is eternal. Our world will end, but the creative process continues. Death is not final. It's part of an eternal cycle. This is almost a kind of cosmic consolation. Individual things perish, but the process of creation never stops. And fourth, perhaps most importantly, it suggests that the fundamental nature of reality is dynamic, not static. The apeiron is not a dead, inert substance. It's eternally active, eternally creative, eternally generating new possibilities. Reality is fundamentally alive in some sense. Not alive like a biological organism, but alive in the sense of being eternally active and creative. Now I want you to appreciate something about this theory. Anaximander has zero empirical evidence for multiple worlds. None. He can't observe other universes. He can't travel to them. He can't detect them in any way. This is pure speculation, pure philosophical reasoning, and yet, it's not arbitrary speculation. It follows logically from his other principles. If the apeiron is truly infinite and boundless, why would it create only one world? Why would its creative power be limited to what we can observe? If the apeiron is characterized by eternal motion and the constant separation of opposites, why would this process happen only once? If cosmic justice requires that all definite things return to the indefinite, why would this apply only to individual objects and not to entire worlds? So Anaximander follows his reasoning to its logical conclusion, even though that conclusion is unverifiable. Even though it seems wild and speculative, this is intellectual courage. This is the willingness to think beyond the safe and observable. I mean, imagine trying to convince your neighbors in ancient Miletus. So, Anaximander, you're saying there are infinite other universes we can never see or interact with? Yes. And you know this how? Logic. Right. Sure. Infinite invisible universes. Got it. But that willingness to speculate, to follow reason beyond the observable, that's essential to philosophical and scientific progress. Einstein speculated about the nature of space and time before he had evidence. Darwin speculated about evolution before he had a complete fossil record. Quantum physicists speculate about the nature of reality at scales we can't directly observe. Speculation guided by reason is how we extend our understanding beyond the immediately visible. And there's one more aspect of this theory I want to highlight. The idea of eternal cycles, creation, destruction, rebirth, appears in many philosophical and religious traditions. The Hindu concept of cosmic cycles, the Stoic idea of eternal recurrence, Nietzsche's eternal return. Why does this idea keep appearing? Why do different cultures and thinkers, separated by time and space, arrive at similar concepts? Maybe because it resonates with something deep in human experience. We see cycles everywhere, day and night, seasons, life and death, civilizations rising and falling. And when we think about the cosmos as a whole, it's natural to wonder, is the universe itself part of a larger cycle? Anaximander says, yes. Not just our individual lives, not just human civilizations, but entire worlds are part of an eternal cycle of creation and return. This is philosophy at its most ambitious, trying to grasp the ultimate structure of all reality. So now we've seen Anaximander's complete cosmological vision. Earth floating freely in equilibrium at the center, celestial wheels of fire moving in perfect circles, and our entire cosmos, just one of infinite worlds, emerging from the boundless apeiron, existing for a time, then returning to the infinite. It's wrong in its details, but it's magnificent in its ambition and its method. Now you might be thinking, this is all very abstract and cosmic, but did Anaximander do anything practical? Did he contribute anything to everyday life and knowledge? Absolutely. Because here's the thing about great philosophers, they work at multiple levels simultaneously. Abstract metaphysics and practical applications. So let's shift gears. Let's look at Anaximander, the geographer, the cartographer, the inventor. Let's see how his philosophical principles translated into concrete tools that changed how people understood and navigated their world. Because Anaximander didn't just theorize about the cosmos from his armchair. He got his hands dirty. He made things. He created tools. He made the first map of the world. He brought the sundial to Greece. He measured time and space with unprecedented precision. And all of it, flows from the same philosophical principles we've been exploring. Let's see how abstract philosophy becomes practical science. Alright, so we've been floating around in cosmic speculation, infinite universes, wheels of fire, the boundless apeiron. Pretty heady stuff. But now let's come back down to earth, literally. Because Anaximander wasn't just a theoretical philosopher sitting around thinking deep thoughts. He was also a practical thinker who created tools that people could actually use. And one of his most important practical contributions was this. He created the first known map of the world. The first map. Not the first Greek map. The first known map in human history. Now, that's not quite accurate. The Babylonians had made some earlier maps. But Anaximander's map was different. It was the first attempt to create a comprehensive, systematic representation of the entire known world based on rational principles rather than religious or mythological geography. So what does it mean to create a map? What are you actually doing? Think about it. A map is an abstraction. You're taking the three-dimensional, messy, complex reality of the physical world and representing it in 2 dimensions on a flat surface. You're making choices about what to include and what to leave out, what to emphasize and what to minimize, how to represent distances, directions, relationships between places. This requires sophisticated abstract thinking. You have to be able to mentally step back from the world as you experience it, walking through it, sailing across it, and imagine it from a perspective you can never actually occupy. You have to imagine looking down on the world from above, seeing it as a whole, understanding its structure. This is the same kind of abstract reasoning Anaximander used for his cosmology. He imagined Earth from a cosmic perspective, seeing it as a cylinder floating in space, even though he could never actually observe it from that vantage point. Now he's doing the same thing for geography, imagining the world from a bird's-eye view, creating a representation that helps people understand spatial relationships they could never directly perceive. Do you see the connection? The same philosophical method, abstract reasoning, systematic thinking, creating models of reality, applies to both cosmic speculation and practical cartography. Now, Anaximander's map depicted Earth as a flat, circular disk with the Mediterranean Sea at its center. Okay, so he got the flat part wrong. Earth is spherical, as later Greeks figured out. But remember what I keep saying. What matters is the method, not just the specific results. Why a circle? Because circles represent perfection, completeness, wholeness. The circle is a geometric form that encloses space completely, with every point on the circumference equidistant from the center. This fits with Anaximander's broader philosophical vision. The cosmos is ordered, rational, geometric. So of course the world would be circular. And why the Mediterranean at the center? Well, from a Greek perspective in 600 BC, the Mediterranean was the center of the known world. It's where Greek colonies were located. It's where trade happened. It's what connected the different regions Greeks knew about. But here's what's important. Anaximander wasn't just drawing what he personally knew. He was trying to incorporate all the geographical knowledge available to the Greeks at that time. Reports from traders who'd sailed to distant lands, stories from travelers who'd journeyed to Egypt, to Persia, to the Black Sea region, accounts of distant peoples and places. He was synthesizing information from multiple sources, trying to create a comprehensive picture. This is systematic knowledge building. This is the scientific approach. Gather all available data, organize it rationally, create a coherent model. And look at this. Anaximander divided the known world into Europe and Asia, with the boundary at the Black Sea. Now this might seem simple to us. Of course there are different continents. But Anaximander was one of the first to think about the world in terms of large-scale geographical divisions. He's not just listing cities or regions. He's thinking about the structure of the world, how it's organized, what the major divisions are. This is geographical theory, not just geographical description. And notice, once again, the impulse toward systematization, toward organization, toward finding rational principles that structure reality. The cosmos is organized into concentric wheels of fire. The world is organized into continental divisions. Everything has structure. Everything has order. Everything can be understood and represented systematically. Now here's what makes Anaximander's map truly revolutionary. Before this, geography was largely mythological. Maps, to the extent they existed, showed the world as the gods had arranged it. Sacred places were at the center. Mythical lands and creatures were included. But Anaximander's map is based on observation and reason. He includes places that traders have actually visited. He represents distances based on travel reports. He organizes the world according to rational principles of spatial relationship. This is the same revolution we saw in his cosmology and metaphysics. Instead of explaining the world through mythology, the gods put the lands here. He's explaining it through natural observation and rational organization. Instead of putting sacred or mythical places at the center, he puts the Mediterranean, the actual hub of Greek trade and travel. This is secular geography. This is geography as a science. not a religious doctrine. And this map had real practical value. Sailors could use it to understand the relationships between different ports and coastlines. Traders could use it to plan routes and understand distances. Military commanders could use it to understand the geography of regions they might campaign in. This is philosophy serving practical human needs. This is abstract thinking producing concrete tools that make life better. And that's important to understand about ancient philosophy. It wasn't just idle speculation. It was often deeply connected to practical concerns, to improving human life, to giving people tools for navigating their world. But I want you to think about something deeper here. A map is a model of reality. It's not reality itself. It's a representation, an abstraction, a tool for understanding reality. And here's the key insight. The map is useful because it's not identical to reality, because it simplifies, organizes, structures. This is true of all scientific models. They're not meant to be perfect copies of reality. They're meant to be useful tools for understanding and predicting reality. Newton's laws aren't true. In some absolute sense, Einstein showed they break down at high speeds, but they're incredibly useful for most purposes. The periodic table is a model, an organization of elements. Reality doesn't come pre-organized that way. But it's an incredibly useful model, and Anaximander understood this. He understood that you can create representations of reality that are useful even if they're not perfect copies. His map was wrong about Earth being flat, but it was useful for understanding the relationships between different regions of the known world. His cosmology was wrong about wheels of fire, but it was useful for thinking systematically about celestial motions. This is a sophisticated epistemological insight. The understanding that knowledge is about creating useful models, not perfect mirrors of reality. And Anaximander is demonstrating this insight through his practical work, not just his theoretical philosophy. Now, creating a map requires something else. A way to measure space and time accurately. A way to determine directions, track the sun's movement, mark the seasons. And Anaximander had a tool for that too. A tool he brought to Greece from Babylon, and which revolutionized Greek science. Let's talk about the gnomon. Okay, so what's a gnomon? It's a stick. A vertical rod, you stick it in the ground and it casts a shadow. That's it. A stick casting a shadow. And with this simple device, this stick in the ground, Anaximander revolutionized Greek science. Now, Anaximander didn't invent the gnomon. The Babylonians had been using sundials for centuries. They had sophisticated astronomical knowledge, detailed star catalogs, mathematical techniques for tracking celestial movements. But Anaximander brought this technology to Greece. He introduced the Greeks to the gnomon and showed them what it could do. And this is important to understand about ancient science. It was often international. Knowledge flowed between cultures. Egyptian mathematics influenced Greek geometry. Babylonian astronomy influenced Greek cosmology. Persian philosophy influenced Greek thought. Miletus, remember, was at the crossroads of civilizations. Ships came in from everywhere, bringing not just goods but ideas. Mathematical techniques, astronomical observations, technological innovations. And Anaximander, curious, systematic, always looking for better tools, saw the Babylonian gnomon and thought, we need this in Greece. This can help us understand the cosmos. So he brought it back. He introduced it. He showed the Greeks how to use it, and it changed everything. So how does a gnomon work? You place a vertical rod in the ground. As the sun moves across the sky, the shadow cast by the rod moves too. And by marking where the shadow falls at different times, you can track the passage of time. In the morning, when the sun is in the east, the shadow points west and is long. At noon, when the sun is directly overhead, or as close as it gets at your latitude, the shadow is shortest. In the afternoon, as the sun moves west, the shadow points east and lengthens again. This is precise timekeeping. Not just morning, noon, evening, but specific hours that you can mark and measure. Before this, Greeks had rough ways of telling time. Water clocks, the position of stars. But the gnomon gave them a simple, accurate, reliable way to track the sun's daily movement and divide the day into measurable units. This is crucial for organizing social life, for coordinating activities, for creating schedules. I mean, try running a civilization without accurate timekeeping. When should we meet? Oh, sometime when the sun is kind of high-ish. Great, super helpful. The gnomon made precise time measurement accessible to everyone. You didn't need expensive equipment or specialized knowledge. Just a stick and the sun. But the gnomon does something even more important than daily timekeeping. It tracks the seasons. Here's what happens. The sun's path across the sky changes throughout the year. In summer, the sun rises farther north, climbs higher in the sky, sets farther north. Days are longer. The noon shadow is shorter. In winter, the sun rises farther south, stays lower in the sky, sets farther south. Days are shorter. The noon shadow is longer. And by tracking the length of the noon shadow day by day, you can identify the exact moments when the sun reaches its extremes, the summer and winter solstices, and when it crosses the midpoint, the spring and autumn equinoxes. This is astronomical observation. This is systematic tracking of celestial phenomena, and it's not just interesting, it's useful. Knowing the solstices and equinoxes means you can create a calendar. You can predict the seasons. You can know when to plant crops, when to expect harvest, when winter is coming. Anaximander used the gnomon to create the first Greek calendar based on astronomical observation rather than just tradition or rough seasonal markers. This is science serving agriculture, serving society, serving human flourishing, but the gnomon enables even more sophisticated work. By carefully measuring shadow lengths at different times of year, you can calculate the angle of the sun's path across the sky. And from that, you can determine your latitude, how far north or south you are on Earth's surface. Here's how. The angle of the sun at noon varies with latitude. If you're at the equator, the sun passes directly overhead twice a year. If you're farther north, it never quite reaches directly overhead. By measuring the maximum height the sun reaches, which you can calculate from the minimum shadow length, you can determine your latitude. This is mathematical astronomy. This is using geometry to understand your position on Earth. And it's not just theoretical, it's practical. Sailors could use this to navigate. Geographers could use this to map the world more accurately. Astronomers could use this to understand Earth's relationship to the celestial sphere. Remember Anaximander's map? The gnomon helped make that map more accurate. By determining the latitudes of different cities, he could represent their positions more precisely. Everything connects. The practical tools support the theoretical work. The theoretical understanding guides the practical applications. The gnomon as bridge between theory and practice. Now I want you to step back and think about what the gnomon represents in Anaximander's broader philosophical project. The gnomon is a tool that bridges the gap between abstract theory and concrete observation. Anaximander has this grand cosmological theory. Earth floating in space, celestial wheels of fire, the apeiron generating infinite worlds. But he's not content with pure speculation. He wants to test his ideas. He wants to measure the cosmos. He wants to gather data. And the gnomon gives him that ability. By tracking the sun's movement precisely, he can test his theories about celestial motions. By measuring shadow lengths at different locations, he can gather data about Earth's shape and size. By creating a calendar based on astronomical observations, he can demonstrate that the cosmos operates according to regular, predictable laws. This is the scientific method in embryonic form. Theory guides observation. Observation tests and refines theory. Tools enable both. And Anaximander understood this. He understood that philosophy needs instruments. That abstract reasoning needs to be grounded in careful observation. That speculation needs to be disciplined by measurement. And the gnomon had profound cultural effects beyond just science. It changed how Greeks thought about time. Time became something measurable, divisible, precise, not just a vague flow of moments. It changed how they thought about space. Latitude and longitude became meaningful concepts. Geography became mathematical. It changed how they thought about the cosmos. The regular, predictable movements of celestial bodies became observable facts, not just theoretical claims. Imagine being a Greek in the generation after Anaximander introduced the gnomon. Suddenly, there's this device in the town square, a vertical rod casting a shadow, and every day people can watch the shadow move, marking the hours. They can see the seasons change as the shadow lengthens and shortens. The cosmos becomes visible. The abstract becomes concrete. The theoretical becomes practical. This is philosophy transforming culture. This is abstract thinking, producing tools that change how people live their daily lives. And it all flows from Anaximander's fundamental philosophical commitment that the world is rational, ordered, comprehensible, and that we can understand it through observation and reason. But I want to suggest something more. The gnomon is also a metaphor for Anaximander's entire philosophical approach. The gnomon is simple, just a vertical rod, but it reveals complex truths: the sun's path, the seasons, your position on earth. Similarly, Anaximander's philosophical method is based on simple principles: observation, reason, systematic thinking. But it reveals complex truths: the structure of the cosmos, the nature of reality, the origin of life. The gnomon works by casting shadows, making the invisible, the sun's movement, visible through its effects. Similarly, Anaximander's philosophy works by inference, making the invisible, the apeiron, the structure of the cosmos, comprehensible through its effects. The gnomon stands upright, pointing toward the heavens while casting its shadow on the earth. Anaximander's philosophy reaches toward the infinite and abstract, the apeiron, cosmic justice, while remaining grounded in practical observation and human needs. So the gnomon is not just a tool Anaximander used, it's a symbol of his entire philosophical project, the attempt to bridge heaven and earth, theory and practice, the abstract and the concrete. So let's recap where we've been. We started with Anaximander's cosmology: Earth floating in space, wheels of fire, infinite worlds emerging from the boundless apeiron. Then we saw his cartography, the first systematic map of the world, organizing geographical knowledge rationally. Now we've seen his chronology, the gnomon enabling precise measurement of time and astronomical phenomena. And it's all connected. It's all part of one coherent philosophical vision. The cosmos is rational and ordered, so we can map it, measure it, understand it. Reality operates according to natural laws, so we can observe those laws, track their effects, predict their outcomes. Human reason can grasp the structure of the world, so we should build tools that extend our observational powers and test our theories. This is what a complete philosophical system looks like. Not just abstract speculation, but a unified vision that encompasses metaphysics, cosmology, geography, astronomy, and practical tool-making. Anaximander didn't just think about the world. He gave us tools to understand it, measure it, navigate it. But we're not done yet. Because Anaximander made contributions in one more area, an area that's going to absolutely blow your mind when you realize how far ahead of his time he was. We need to talk about his biological theories. We need to talk about how Anaximander in 600 BC proposed ideas about the origin of life and human evolution that wouldn't be fully developed until Darwin 2,400 years later. This is where it gets really wild. Because here's what Anaximander realized. Human babies are helpless. They need years of care to survive. So if the first humans were born as helpless infants, they would have died immediately. No one to care for them. Therefore, and this is the logical leap, the first humans must have developed inside other creatures until they were mature enough to survive on their own. This is evolutionary thinking in 600 BC. Let me show you how he got there. Alright, buckle up. Because what we're about to discuss is genuinely mind-blowing. We've seen Anaximander revolutionize cosmology, geography, astronomy. We've seen him create tools, make maps, measure time. But now, we're going to see him tackle one of the most profound questions humans have ever asked. Where did we come from? And his answer in 600 BC, anticipates evolutionary theory by 2,400 years. Let me say that again. 2,400 years before Darwin, Anaximander proposed that humans evolved from other life forms. Now, he didn't have natural selection, he didn't have genetics, he didn't have fossils or comparative anatomy or any of the evidence Darwin would use. But he had something powerful: logic, pure reasoning. The ability to think through a problem and follow it to its conclusion. And that reasoning led him to one of the most important insights in the history of biology. Here's how Anaximander's reasoning went. Observe human infants. What do you notice? They're completely helpless. Can't feed themselves, can't walk, can't protect themselves from predators, can't survive even a day without intensive care. Human babies need years, literally years, of constant attention and care before they can survive independently. This is unusual in the animal kingdom. Most animals can walk within hours or days of birth. Many can find food relatively quickly. But humans? were helpless for an extraordinarily long time. Now here's Anaximander's brilliant logical move. If humans have always existed in our current form, and if the first humans were born as helpless infants, then who took care of them? There were no parents yet, there were no adults to provide care. The first human babies would have been born into a world with no one to feed them, protect them, raise them. They would have died immediately. Therefore, and this is the key inference, humans could not have always existed in their current form. We must have developed differently. We must have originated in some other way. And Anaximander proposes, early humans must have developed within other creatures until they were mature enough to survive on their own. So where did life begin? Anaximander proposes, in water. Specifically, in warm, shallow seas. Now why water? First, water is essential for all life as the Greeks knew it. Nothing lives without water. So it makes sense that life would originate in water. Second, water provides support. In water, creatures don't need strong skeletons immediately. The water holds them up. This makes it easier for early simple life forms to exist. Third, warm, shallow seas provide a stable environment. Not too hot, not too cold, with sunlight penetrating to provide energy. And here's what's remarkable. Modern biology agrees. The current scientific consensus is that life originated in water, probably in shallow seas or tidal pools where organic molecules could concentrate and interact. Anaximander, using pure reasoning about what conditions life requires, arrived at essentially the correct answer. Now, Anaximander gets more specific. He proposes that the first creatures resembled fish, specifically fish with spiny, protective coverings. Why this specific form? Think about what early life would need. Protection. The ability to survive in water. Some way to obtain nutrients. Fish have all of these. And spiny fish, fish with hard protective scales or shells, have extra protection against predators and environmental hazards. Anaximander is reasoning from function to form. What functions would early life need? Protection, nutrition, mobility in water. What form provides those functions? Something fish-like with protective coverings. Now, he's wrong about the specific details. The first life forms were single-celled organisms, not fish. But he's right about the general principle. Life started simple, in water, with basic protective structures. And he's right about something even more important. Life forms are adapted to their environments. They have features that help them survive in specific conditions. This is proto-evolutionary thinking. This is understanding that form follows function, that organisms are shaped by the demands of survival. But here's where it gets really interesting. Anaximander doesn't just say life originated in water and stayed there. He proposes that creatures changed over time to survive in different environments. Specifically, some aquatic creatures gradually adapted to survive on land. This is the concept of adaptation. This is the idea that organisms change in response to environmental pressures. This is evolutionary thinking. Now, Anaximander doesn't have the mechanism. He doesn't know about natural selection, about genetic variation, about inheritance of traits. But he has the core insight. Life forms are not fixed and unchanging. They transform over time. They adapt to new environments. How did he get here? Probably through observation and logic. Observation. There are creatures that live in water, fish, and creatures that live on land. Mammals, reptiles, birds. They're different, but they share some basic features. They eat, they move, they reproduce. Logic. If life originated in water, but there are now land creatures, then some water creatures must have transitioned to land. Question. How? Answer. They must have gradually changed, adapted, developed features that allowed them to survive out of water. This is brilliant reasoning. This is using observation and logic to reconstruct a past you can never directly observe. This is exactly what Darwin would do 2,400 years later. Observe the diversity of life, reason about how it could have arisen, propose a mechanism of change over time. And now we come to the most radical part of Anaximander's theory. Humans developed from fish-like ancestors. In 600 BC, Anaximander is proposing that humans share ancestry with fish, that we are not a separate, special creation, but part of the same natural process that produced all life, that we evolved from earlier, simpler forms. Here's how he envisions it. early fish-like creatures in the primordial seas. Some of them develop the ability to survive on land. Maybe they develop lungs or limbs or protective skin. Among these land-adapted creatures, some develop further, becoming more complex, more capable, and eventually, through this process of gradual change and adaptation, humans emerge. But, and this is the key insight we discussed earlier, the first humans couldn't have been born as helpless infants. So Anaximander proposes they developed inside these fish-like ancestors, protected and nourished, until they were mature enough to survive independently. Now, the specific mechanism is wrong. We didn't gestate inside fish, but the general principle is right. Humans evolved from earlier life forms. We share common ancestry with other animals. We are part of the same evolutionary tree. This is one of the most important ideas in the history of biology, and Anaximander proposed it in 600 BC. Now let's step back and appreciate the method Anaximander is using here. He starts with an observation. Human babies are helpless. He identifies a logical problem. If humans always existed this way, the first babies would have died. He draws a conclusion. Therefore, humans must have originated differently. He looks for a mechanism, development within other creatures until maturity. He builds a broader theory. Life originated in water, adapted to land, gradually changed over time. This is rigorous logical reasoning. This is the scientific method. Observe a phenomenon, identify a problem or question, propose a hypothesis, build a broader explanatory framework. And he's doing this without any of the tools we take for granted. No fossils to examine. Paleontology doesn't exist yet. No comparative anatomy. Biology as a systematic discipline doesn't exist yet. No genetics. The concept of heredity is barely understood. Just observation, reason, and the courage to follow logic wherever it leads. Now, why does this matter so profoundly? First, Anaximander has naturalized human origins. We're not special creations of the gods. We're part of the natural world, subject to the same processes as other life forms. This is radical. This is saying humans are continuous with nature, not separate from it. Second, he's proposed that the past was different from the present, that life forms change over time, that the world has a history of transformation. This is the beginning of historical thinking in biology, the understanding that to explain the present, you need to understand the past. Third, he's shown that you can use reason to reconstruct events you can never directly observe. You can infer the past from the present. You can build theories about origins. This is crucial for all historical sciences: geology, cosmology, evolutionary biology. They all depend on this insight. And fourth, perhaps most importantly, he's demonstrated that humans are part of the rational order of nature. We're not exceptions to natural law. We're not outside the cosmos looking in. We're part of it, products of the same processes that produced everything else. This is both humbling and empowering. Humbling because we're not special. Empowering because it means we can understand ourselves through the same methods we use to understand everything else. Now let's be clear about what Anaximander got wrong. He didn't understand the mechanism of evolution, natural selection, genetic variation, inheritance. He didn't have the timescale right. Evolution takes millions of years, not generations. He didn't understand the complexity of the evolutionary tree, the branching, the extinctions, the radiations. His specific proposal, humans gestating inside fish, is wrong. But here's what he got right. Life originated in water, correct. Life forms change over time, correct. Humans evolved from earlier, simpler forms, correct. Organisms are adapted to their environments, correct. You can use reason to understand origins, correct. In other words, he got the fundamental insights right, even if he lacked the detailed mechanisms. And that's what makes him a pioneer, not because he had all the answers, but because he asked the right questions and pointed in the right direction. Now, Anaximander didn't stop with cosmology, geography, and biology. He also tackled meteorology, the explanation of weather phenomena, and once again we're going to see him doing the same thing, rejecting mythological explanations in favor of natural ones. Using observation and reason to understand the world, let's see how he explained wind, rain, thunder, and lightning. Alright, so imagine you're an ancient Greek. You want to know why it rains. You go to the traditional authorities, the priests, the poets, the keepers of mythology, and they tell you, rain is the tears of the gods. When Zeus mourns, the sky weeps. Or, rain is a gift from the gods, blessing the earth with fertility. Beautiful, poetic, meaningful, and completely unverifiable. Now you go to Anaximander, you ask him, why does it rain? And he says, water evaporates from the sea, rises into the air, cools, condenses, and falls back to earth. No gods, no divine tears, no supernatural intervention, just natural processes. Observable phenomena, mechanical explanations. This is the meteorological revolution. Look at this table on the slide. It shows the contrast between mythological explanations and Anaximander's natural explanations for 4 phenomena: wind, rain, thunder, and lightning. Let's go through each one and understand not just what Anaximander proposed, but why his approach was revolutionary. Mythological explanation. Wind is the breath of the gods. Aeolus, god of winds, releases them from his cave. The gods breathe upon the world. Anaximander's explanation. Wind is moving air currents. Now this might seem obvious to us. Of course wind is moving air. What else would it be? But think about what this represents philosophically. The mythological explanation is intentional. Wind happens because a god wants it to happen. It has purpose, meaning divine will behind it. Anaximander's explanation is mechanical. Wind happens because air moves. No intention, no purpose, just physical process. This is a complete shift in how we understand causation. From things happen because gods will them, to things happen because of natural processes. From intentional explanation to mechanical explanation. From theology to physics. How did Anaximander arrive at this? Probably through observation and reasoning. You can feel wind. It's clearly something material, not just invisible divine breath. Wind varies in strength and direction. It's not uniform, suggesting it's caused by local conditions, not divine decree. Wind seems to be related to temperature and weather patterns, hot days, storms, etc. Conclusion: wind is air in motion, driven by natural causes like temperature differences. Rain, from divine tears to evaporation cycle. Mythological explanation: rain is tears of deities, or divine blessing poured from the heavens. Anaximander's explanation: evaporated water returning to earth. Here's Anaximander's reasoning. Observation: water disappears from wet surfaces over time. It evaporates. Observation: clouds appear to be made of water or mist. They're wet when you're in them, on mountains. Observation: rain falls from clouds. Logical inference: the water that evaporates must go somewhere. It must rise into the air. It must form clouds, and then it must fall back down as rain. This is the water cycle. This is understanding that matter is conserved, that water doesn't just disappear and reappear. It transforms and moves through different states. This is sophisticated scientific thinking. And notice what Anaximander is doing. He's connecting different observations into a unified explanation. Evaporation, clouds, and rain aren't separate, unrelated phenomena. They're parts of one continuous process. This is systems thinking. This is understanding that nature operates through interconnected processes. Mythological explanation: thunder is Zeus's anger, the sound of his divine wrath. Anaximander's explanation: colliding air masses. Now this is more speculative on Anaximander's part. He couldn't directly observe what causes thunder, but he's trying to find a natural, mechanical explanation. He'd probably reason something like this. Thunder accompanies storms, which involve wind and rain, moving air and water. Thunder is a sound. Sounds are caused by impacts, collisions, vibrations. Therefore, thunder is probably caused by air masses colliding or moving violently during storms. Now, the modern explanation is more complex. Thunder is caused by the rapid expansion of air heated by lightning. But Anaximander is on the right track. He's right that it's a natural phenomenon involving air movement. He's right that it's mechanical, not divine. He's right that it's connected to storm dynamics. And what matters is the approach. Don't accept "the gods are angry" as an explanation. Look for natural causes. Propose mechanisms. Connect the phenomenon to other observable processes. Mythological explanation: lightning is Zeus's weapon, divine thunderbolts hurled from heaven. Anaximander's explanation: wind breaking through clouds. This is Anaximander's most speculative meteorological explanation, and it's the furthest from the modern understanding. Lightning is actually electrical discharge. a phenomenon Anaximander had no way to understand. Electricity wouldn't be discovered for over 2,000 years. But look at what he's trying to do. He observes that lightning happens during storms when there's wind and clouds. He needs a mechanical explanation, something involving natural forces, not divine intervention. He proposes, maybe the wind, moving violently, breaks through the clouds, and the breaking creates the flash. Is this right? No. Is it a reasonable attempt given his knowledge? Absolutely. He's working with what he can observe: wind, clouds, the timing of lightning during storms, and he's proposing a mechanism that involves only natural forces. And here's what's important. He's willing to be wrong. He's proposing testable ideas. Ideas that could, in principle, be verified or falsified through observation. This is the scientific attitude. Propose explanations, test them, refine them, be willing to be wrong in pursuit of better understanding. Now step back and look at what Anaximander has accomplished here. For every major weather phenomenon, wind, rain, thunder, lightning, he's replaced a mythological explanation with a natural one. He's saying, the world doesn't need gods to explain weather. Natural processes are sufficient. This is radical naturalism. This is the complete secularization of meteorology, and it's part of his broader philosophical project. The cosmos operates according to rational, natural laws. Everything can be explained through observation and reason. We don't need to invoke the supernatural, but there's something even more profound happening here. Anaximander is changing the very nature of explanation. Before, explanations were intentional. Why does it rain? Because the gods will it. After, explanations are mechanical. Why does it rain? Because water evaporates and condenses. Intentional explanations answer why in terms of purpose and will. Mechanical explanations answer how in terms of process and cause. Anaximander is saying, for natural phenomena, mechanical explanations are better. They're more precise, they're testable, they allow prediction and understanding. This is the birth of scientific explanation. This is the foundation of all modern meteorology, physics, chemistry, any science that explains natural phenomena through natural processes, the limits of his knowledge. Now, let's be clear. Anaximander's specific explanations are often wrong or incomplete. Wind isn't just moving air. It's caused by pressure differences, temperature gradients, the Earth's rotation. Rain isn't just evaporated water returning. There are complex processes of condensation, cloud formation, precipitation. Thunder isn't just colliding air masses. It's caused by the shock wave from lightning's heat. Lightning isn't wind breaking through clouds, it's electrical discharge, but he's right about the fundamental approach. Weather phenomena have natural causes. Correct. They involve processes we can observe and study. Correct. They're connected to each other in systematic ways. Correct. We can explain them without invoking the supernatural. Correct. And that's what matters. Not that he got every detail right. How could he? Without thermometers, barometers, understanding of electricity, knowledge of atmospheric physics. What matters is that he established the right method. Observe carefully. Reason systematically. Propose natural mechanisms. Build explanatory frameworks. Now imagine the cultural impact of this shift. For centuries, weather had been understood as the domain of the gods. You wanted rain? You prayed. You made sacrifices. You tried to appease divine powers. But Anaximander is saying, weather is natural. It follows laws. Understanding those laws is more useful than appeasing gods. This is empowering. This is saying, you can understand the world. You can predict weather patterns. You can make rational decisions based on natural knowledge. Of course, this doesn't mean the Greeks immediately abandoned religious explanations. Mythology and natural philosophy coexisted for centuries. But Anaximander opened a door. He showed that natural explanation was possible, that you could understand weather without invoking the gods. And once that door is open, you can't really close it again. And notice how this fits with everything else we've seen from Anaximander. In cosmology, natural explanations for celestial phenomena, not divine chariots. In biology, natural processes of evolution, not special creation. In meteorology, natural causes for weather, not divine intervention. It's all part of one coherent vision. The cosmos is rational, ordered, comprehensible through natural law. The apeiron generates worlds through natural processes. Life emerges and evolves through natural processes. Weather happens through natural processes. Everything is connected. Everything follows from the same fundamental principles. This is what a complete philosophical system looks like. Not just isolated ideas, but a unified vision that explains everything from the cosmic to the everyday. From the infinite apeiron to the rain falling on your head. It's all part of one rational, comprehensible order. Now we've covered Anaximander's major contributions: cosmology, geography, biology, meteorology. We've seen his practical innovations: the map, the gnomon. But there's one more thing we need to discuss. What did Anaximander actually write? How do we know all this? What evidence do we have? Because here's the thing, and this is going to frustrate you. Almost nothing of Anaximander's actual writings survived. We have fragments, references, second-hand accounts. But from these fragments we can reconstruct one of the most important philosophical projects in human history. Let's talk about what we have, what we've lost, and how we know what we know. Anaximander wrote a book. Probably the first philosophical book ever written in prose rather than poetry. It was called On Nature, periphysios in Greek, and it's lost, gone, destroyed by time, fire, neglect, the collapse of civilizations. We have one sentence, one fragment in his own words. Everything else? Reconstructed from what later philosophers said about him. But that one sentence and those second-hand accounts are enough to show us a mind of extraordinary power and vision. Let me show you what we have and what it tells us. Alright, so we've spent all this time exploring Anaximander's revolutionary ideas, his cosmology, his biology, his geography, his meteorology, and you might be wondering, how do we know all this? Where did this information come from? Great question, and the answer is going to frustrate you. We have one sentence, one fragment in Anaximander's actual words that survived 2,600 years. One sentence. Everything else, this entire philosophical system we've been exploring, has been reconstructed from second-hand accounts, from later philosophers who read Anaximander and commented on his ideas, from doxographers, ancient scholars who compiled summaries of philosophical positions. We're looking at Anaximander through a veil, through multiple layers of interpretation and transmission. And yet, and this is what's remarkable, we can still see the power and originality of his thought shining through. So what did Anaximander actually write? He composed a work called On Nature, periphysios in Greek. And this work was groundbreaking for a reason that might not be immediately obvious. It was written in prose. Now you might think, so what? Why does it matter whether it's prose or poetry? It matters enormously. Let me explain. Before Anaximander, philosophical and cosmological ideas were transmitted through poetry. Homer's epics, Hesiod's theogony. These were the texts that explained the origin of the world, the nature of the gods, the structure of reality. And poetry has certain characteristics. It's memorable. The meter and rhythm help you remember it. It's beautiful. The aesthetic quality gives it authority. It's traditional. It connects to established forms and conventions. But poetry also has limitations. Poetry prioritizes beauty over precision. It uses metaphor and imagery that can be ambiguous. It's harder to argue with. How do you critique a beautiful verse? Anaximander chose prose. Plain, straightforward prose. And this choice is revolutionary. Prose is precise. You can make clear, unambiguous statements. Prose is argumentative. You can build logical chains of reasoning. Prose is accessible to critique. Someone can point to a specific claim and say, I disagree, and here's why. By writing in prose, Anaximander is saying, philosophy is not about beautiful stories passed down from tradition. It's about clear thinking, logical argument, and ideas that can be examined and debated. He's creating a new form of discourse, a new way of pursuing truth. And this innovation, prose philosophical writing, becomes the standard. Plato writes in prose, albeit very beautiful prose. Aristotle writes in prose. Every major Western philosopher after Anaximander writes in prose. Anaximander invented the form that philosophy would take for the next 2,600 years. But here's the tragedy. On Nature is lost. We don't have it. We don't have a complete copy. We don't even have substantial fragments. What happened? How does a groundbreaking philosophical work, one of the most important books ever written, just disappear? Well, books in the ancient world were fragile. They were written on papyrus scrolls that deteriorated over time. They had to be copied by hand to survive, and copying was expensive and time-consuming. So books survived only if people kept copying them, if they were considered important enough, valuable enough, to justify the expense and labor of copying. And here's the problem. As philosophy developed, as new thinkers emerged, earlier works sometimes seemed outdated. Why copy Anaximander when you have Plato and Aristotle, who built on his ideas and went further? So copies of On Nature became rarer. Libraries burned. The Great Library of Alexandria, for instance. Civilizations collapsed. The fall of Rome. Knowledge was lost. And eventually, sometime in late antiquity or the early Middle Ages, the last copy of Anaximander's On Nature disappeared. Gone. Lost to history. But, and this is crucial, the ideas survived. Because later philosophers, Aristotle, Theophrastus, Simplicius, others, had read Anaximander. They quoted him. They summarized his positions. They argued with him. And their works survived. So through them, we can reconstruct what Anaximander thought. It's like trying to understand a conversation by hearing only one side of it. You have to infer what the other person said based on the responses. That's what we're doing with Anaximander. Reconstructing his philosophy from the responses and references of later thinkers. But we do have one fragment, one sentence in Anaximander's actual words, preserved by a later philosopher named Simplicius. Let me read it to you again. We discussed it earlier, but now you'll appreciate it differently, knowing it's the only direct voice we have. The things that are perish into the things from which they come to be, according to necessity, for they pay penalty and retribution to each other for their injustice according to the assessment of time. This is it. This is the only sentence we have in Anaximander's own words, and it's profound. The things that are perish into the things from which they come to be. Everything returns to its source, the cycle of emergence and return. According to necessity. This isn't random. It's governed by natural law. They pay penalty and retribution to each other for their injustice. The separation from the apeiron is an injustice that must be corrected. According to the assessment of time, this happens over time, in due course, according to temporal order. In one sentence, one beautiful, profound sentence, Anaximander captures his entire cosmological vision, the apeiron as source and destination, the cycle of creation and return, cosmic justice, natural necessity, the role of time in cosmic processes, and notice the language, injustice, penalty, retribution. These are moral and legal terms applied to cosmic processes. Anaximander is saying, the universe itself has a kind of moral structure, not human morality, but cosmic justice, balance, equilibrium, the correction of imbalances. This is philosophy at its most poetic and profound, even while being written in prose. So what can we know with confidence about Anaximander's thought? We know he proposed the apeiron as the first principle. This is attested by multiple sources. We know he theorized about Earth's position and shape. Aristotle discusses this. We know he created a map and brought the gnomon to Greece. Historical records confirm this. We know he proposed evolutionary ideas about human origins. Later doxographers report this. We know he sought natural explanations for meteorological phenomena. This is mentioned in several sources. But we don't know the details of his arguments. We don't know exactly how he phrased things. We don't know what examples he used, what objections he considered, how he responded to critics. We have the broad outlines, the major positions, the revolutionary ideas. But the texture of his thought, the specific arguments, the nuances, the development of ideas, that's lost. And yet, isn't it remarkable that even through this veil of time and loss, we can still see his genius? That even with one sentence and second-hand accounts, we can recognize Anaximander as one of the most important thinkers in human history? That tells you something about the power of his ideas. They were so revolutionary, so influential, So important that they survived even when his actual words didn't. And here's the irony. Anaximander's ideas were so successful that they made his own work obsolete. Later philosophers, Plato, Aristotle, the Stoics, absorbed his insights. They built on his foundations. They developed his ideas further. And because they went further, their works seemed more important to preserve. Why copy the foundation when you have the building? So Anaximander's success contributed to his obscurity. His ideas lived on, but his name and his specific arguments faded. Until modern scholarship started piecing together the history of pre-Socratic philosophy and realized, wait, this guy Anaximander was absolutely crucial. He invented half of what we think of as philosophy. So now we're recovering him, recognizing his importance, giving him his due. Better late than never, I suppose. Though it would have been nice to have his actual book. But even without his complete writings, we can trace his influence. We can see how his ideas shaped the philosophers who came after him. And that influence is enormous. Anaximander didn't just contribute to philosophy, he helped create the very possibility of philosophy as we know it. Let's trace that influence. Let's see how Anaximander's ideas rippled through Greek philosophy and beyond. Alright, so we've established that Anaximander was revolutionary, but how do we measure his actual influence? How do we know he mattered? Simple. We look at what came after him. We trace the lineage. We see how his ideas shaped the entire tradition of Western philosophy. And what we find is this. Anaximander is everywhere. Every major Greek philosopher after him is responding to problems he raised, building on methods he pioneered, working within frameworks he established. He's like the foundation of a building. You don't see it once the building is complete, but without it, nothing else stands. Look at this slide. It shows 4 stages in the development of Greek philosophy. 1. Thales, early foundation. 2. Anaximander, bridge. 3. Anaximenes, direct successor. 4. Pythagoras and Heraclitus, further development. This is the progression from the birth of philosophy to its full flowering. And Anaximander is right in the middle, the crucial bridge between the beginning and what comes after. Let's trace this development carefully. Thales, as we've discussed, was the first. He asked the fundamental question, what is everything made of? And he answered, water. This was revolutionary simply for asking the question in naturalistic terms, not which god created everything, but what natural substance underlies everything. Thales laid the groundwork for pre-Socratic philosophy. He showed that you could seek natural explanations for natural phenomena, but Thales' philosophy was limited. He proposed a concrete, observable substance, water, as the first principle. He didn't develop a systematic cosmology. He didn't write extensively, as far as we know. He didn't create a school or methodology. He started something, but he didn't develop it fully. And this is where Anaximander comes in. Anaximander took Thales' question, what is the fundamental reality? And transformed it. Thales said, a concrete substance, water. Anaximander said, an abstract principle, the apeiron. This is a huge conceptual leap. From the observable to the theoretical. From the concrete to the abstract. From physics to metaphysics. And this is why Anaximander is a bridge. He connects 2 fundamentally different ways of doing philosophy. On one side, Thales' concrete materialist approach, philosophy as the study of physical substances. On the other side, Plato's abstract idealist approach, philosophy as the study of eternal forms and principles beyond physical reality. Anaximander stands between them. He starts with Thales' naturalism, seeking natural explanations, rejecting mythology, but he moves toward abstraction, proposing principles that transcend direct observation. He shows that you can be naturalistic and abstract, that you can seek natural explanations while recognizing that the deepest reality might not be directly observable. Without Anaximander, you don't get Plato. You don't get the idea that philosophy should seek abstract principles underlying appearances. Thales alone doesn't lead to Plato. The gap is too big. But Anaximander bridges that gap. He shows how you can move from concrete observation to abstract theorizing while maintaining rational rigor. Anaximander's direct student was Anaximenes, who continued the Milesian tradition. Anaximenes proposed that air is the fundamental substance. Everything is different forms of air, condensed or rarefied. Now, In some ways, this looks like a step backward. Anaximander had moved to the abstract apeiron, and Anaximenes returns to a concrete substance, air. But actually, Anaximenes is synthesizing his predecessors, from Thales. The idea of a specific observable substance. From Anaximander, the idea of transformation through condensation and rarefaction, which parallels the separation of opposites from the apeiron. So Anaximenes isn't rejecting Anaximander, he's building on him. He's taking Anaximander's insights about transformation and process and applying them to a specific substance. And this shows the health of the Milesian school. Each generation builds on the last, questions the last, refines the last. This is how philosophical progress happens. But Anaximander's influence extends beyond the Milesian school. Pythagoras, working in southern Italy, develops a philosophy based on number and mathematical harmony. Where does this come from? From Anaximander's insight that the cosmos has a rational mathematical structure, that you can use geometry and number to understand reality. Anaximander's cylindrical Earth, his calculations of celestial sizes, his use of the gnomon for astronomical measurement, all of this shows that reality has a mathematical structure. Pythagoras takes this insight and makes it central. All is number. Reality is fundamentally mathematical. Heraclitus, working in Ephesus, near Miletus, develops a philosophy of constant change and transformation. You cannot step in the same river twice. Everything flows. Where does this come from? From Anaximander's vision of cosmic cycles, of worlds emerging and returning to the apeiron, of constant transformation and change. Anaximander showed that reality is dynamic, not static, that the cosmos is characterized by eternal motion and transformation. Heraclitus takes this insight and makes it central. Change is the fundamental reality. Stability is an illusion. Do you see what's happening? Anaximander's ideas are radiating outward, influencing different philosophical schools, inspiring different approaches. He's not just one link in a chain, he's a hub from which multiple philosophical traditions emerge. But Anaximander's influence isn't just about specific ideas. It's about methods, ways of doing philosophy that become standard. Let me identify the key methodological innovations. Anaximander showed that philosophy can deal with entities beyond direct observation. The apeiron can't be seen or touched, but it can be reasoned about. This becomes central to all later philosophy. Plato's forms, Aristotle's prime mover, the Stoic logos, all are abstract principles grasped through reason, not observation. Anaximander didn't just propose isolated ideas, he built a system, a coherent vision encompassing cosmology, biology, meteorology, geography. This becomes the model for later philosophy. Aristotle's comprehensive system, the Stoic system, medieval scholasticism. Philosophy should be systematic, comprehensive, unified. Anaximander used geometry and number to model reality. Earth's cylindrical shape, the sizes of celestial bodies, the gnomon's measurements. This becomes central to Greek science and philosophy. Pythagorean mathematics, Platonic geometry, Aristotelian astronomy. Anaximander consistently sought natural explanations for natural phenomena, rejecting mythological accounts. This becomes the foundation of all science. The assumption that natural phenomena have natural causes that can be discovered through observation and reason. These methods, abstract reasoning, systematic thinking, mathematical modeling, naturalistic explanation, these are the tools of philosophy and science, and Anaximander pioneered all of them. Every time a philosopher builds a systematic theory, they're following Anaximander's example. Every time a scientist uses mathematics to model reality, they're using Anaximander's method. Every time we seek natural explanations rather than supernatural ones, we're honoring Anaximander's commitment. But Anaximander's influence goes even deeper. He didn't just provide answers, he raised questions that philosophy is still grappling with. What is the fundamental nature of reality? Is it material or abstract? One substance or many? Observable or theoretical? Anaximander raised this question in its full depth, and philosophy has been debating it ever since. How can things change while remaining the same? How can the world be both stable and dynamic? Anaximander's vision of emergence from and return to the apeiron raises this problem acutely. How did the world begin? How did life arise? How did humans come to be? Anaximander showed these are philosophical questions, not just mythological ones. Is there a moral structure to reality itself? Does the universe tend toward balance and equilibrium? Anaximander's concept of cosmic justice raises profound questions about the relationship between natural law and moral order. These aren't just ancient questions. These are live philosophical problems. Contemporary metaphysics still debates the nature of fundamental reality. Contemporary philosophy of science still grapples with change and permanence. Contemporary cosmology still investigates origins. Contemporary ethics still asks whether there's a moral structure to the universe. Anaximander didn't just influence ancient philosophy, he set the agenda for philosophy as such. So let's summarize Anaximander's unique position in the history of philosophy. He came after Thales, the first philosopher, and learned from him. But he went far beyond Thales, moving from concrete to abstract, from simple to systematic. He taught Anaximenes, who continued the Milesian tradition. But he also influenced Pythagoras, Heraclitus, and through them the entire Greek philosophical tradition. He stood at the beginning of philosophy, when everything was still being invented. But he invented so much, methods, problems, frameworks, that his influence extends to the present day. Anaximander is the philosopher's philosopher, the thinker who showed what philosophy could be. Not just clever arguments or beautiful poetry, but systematic investigation of reality using observation, reason, and imagination. Not just answering questions, but raising deeper questions. Not just describing the world, but creating tools to understand it. And yet, despite all this influence, despite his revolutionary importance, Anaximander remains relatively obscure. Ask educated people to name ancient Greek philosophers, and they'll say Socrates, Plato, Aristotle, maybe Pythagoras, maybe Heraclitus if they're well read, but Anaximander, most people have never heard of him. And this is tragic, because in many ways, Anaximander is more important than the philosophers everyone knows. Socrates didn't write anything. We know him only through Plato. Plato built on centuries of philosophical development that Anaximander helped create. Aristotle systematized knowledge that Anaximander pioneered. Anaximander is the foundation, he's the beginning, he's the one who showed what philosophy could be, and he deserves to be remembered. He deserves to be celebrated. He deserves to be recognized as one of the most important thinkers in human history. So now, finally, we're going to bring this all together. We're going to step back and ask, what does Anaximander's legacy mean for us today? Why should we care about a philosopher from 2,600 years ago? What is Anaximander's enduring significance? Let me show you why this matters. Not just for understanding ancient history, but for understanding ourselves and our world. Because here's the thing. Anaximander isn't just historically important. He's presently relevant. His ideas, his methods, his questions, his vision, they speak directly to our contemporary situation. In an age of scientific cosmology, evolutionary biology, climate science, and technological innovation, Anaximander has something to teach us. Let me show you how a 2,600-year-old philosopher remains urgently relevant in the 21st century. So we've journeyed through 2,600 years of history. We've explored cosmology, biology, geography, meteorology, metaphysics. We've traced influence, examined methods, assessed contemporary relevance. Now it's time to step back and ask the biggest question. What does it all mean? What is Anaximander's enduring significance for humanity? Why does this one thinker from ancient Miletus deserve our attention, our study, our appreciation? Let me give you 3 answers, 3 dimensions of Anaximander's lasting importance. First, Anaximander laid the groundwork for the scientific revolution that would transform human civilization. Now, the scientific revolution is usually dated to the 16th and 17th centuries, Copernicus, Galileo, Newton, the birth of modern science. But that revolution didn't come from nowhere. It had roots, foundations, precedents. And those foundations were laid in ancient Greece by thinkers like Anaximander. Anaximander showed that natural phenomena have natural causes. This becomes the foundation of all science. He showed that mathematics can model physical reality. This becomes the language of physics. He showed that you can use reason to understand things beyond direct observation. This becomes theoretical science. He showed that systematic observation and logical inference can reveal truths about the world. This becomes the scientific method. Without these foundations, without the framework Anaximander helped create, the scientific revolution couldn't have happened. Galileo could drop balls from towers and observe their motion, but he needed the idea that natural phenomena follow mathematical laws. That idea comes from Anaximander and the tradition he helped establish. Newton could develop gravitational theory, but he needed the concept that objects can be held in place by invisible forces rather than physical support. That concept comes from Anaximander's insight about Earth floating freely. Darwin could propose evolutionary theory, but he needed the framework of naturalistic explanation and historical reconstruction. That framework comes from Anaximander's approach to understanding origins. So when we talk about Anaximander laying groundwork for scientific thought, we're not being metaphorical. We're describing actual historical influence. The methods, questions, and frameworks Anaximander pioneered became the foundation for the scientific worldview that has transformed human civilization. Second, Anaximander bridged mythological and scientific worldviews, showing humanity a new way to understand reality. This is perhaps his most profound achievement. Before Anaximander and the pre-Socratics, human beings understood the world primarily through mythology. Why does the sun rise? Because Helios drives his chariot. Why does it rain? Because the gods will it. Where did humans come from? The gods created us. Now, mythology isn't stupid or primitive. It's a sophisticated way of making sense of the world. It provides meaning, purpose, moral guidance. It connects natural phenomena to human values and experiences. But mythology has limitations. It doesn't allow for systematic prediction or control. It doesn't encourage questioning or testing. It doesn't build cumulative knowledge over time. It doesn't distinguish clearly between natural and supernatural causation. And then Anaximander comes along and says, what if we explained the world differently? What if we sought natural causes, used systematic observation, built testable theories, accumulated knowledge over generations? This is a revolution in human consciousness. This is humanity claiming the right and the ability to understand nature on its own terms, through its own efforts, using its own reason. Now, this transition wasn't simple or complete. Mythology and rational inquiry coexisted for centuries. Many Greek philosophers maintained religious beliefs alongside their philosophical theories. And even today, we haven't fully resolved the relationship between scientific and religious or mythological ways of understanding. But Anaximander showed that rational inquiry is possible, that you can understand the world without invoking gods or supernatural forces. That human reason is powerful enough to grasp the structure of reality. This is empowering. This is liberating. This is saying, you don't have to accept traditional explanations on authority. You can observe, reason, and discover truth for yourself. And this insight, that rational inquiry can reveal truth, becomes the foundation of the Enlightenment, of modern democracy, of universal education, of scientific civilization. Every time you question authority and seek evidence, you're following Anaximander's example. Every time you trust reason over tradition, you're honoring his legacy. Every time you believe that human beings can understand and improve their world through systematic inquiry, you're affirming his vision. Third, Anaximander established key methods of Western philosophy that continue to define the discipline. Let me be specific about what he contributed. Abstract reasoning. Anaximander showed that philosophy can deal with entities beyond direct perception, the apeiron, cosmic justice, fundamental principles. This becomes central to all Western philosophy. Plato's forms. Aristotle's unmoved mover, Kant's noumena, Hegel's absolute spirit. Philosophy is about abstract reasoning, thinking beyond the immediately observable to grasp deeper truths, systematic thinking. Anaximander built comprehensive systems that unified diverse phenomena under common principles. This becomes the model for philosophical work. Aristotle's system, Aquinas' synthesis, Spinoza's ethics, Hegel's system. Philosophy should be systematic, comprehensive, showing how everything connects. Conceptual analysis. Anaximander carefully analyzed concepts. What does it mean for something to be boundless? What is justice at a cosmic level? What is the relationship between the one and the many? This becomes the core method of philosophy: Socratic questioning, Aristotelian definition, contemporary analytic philosophy. Philosophy is conceptual analysis, clarifying what we mean and what follows from our concepts. Thought experiments. Anaximander used reasoning to imagine scenarios beyond direct experience. Earth floating in space, infinite worlds, evolutionary origins. This becomes a key philosophical tool. Plato's cave. Descartes' demon. Rawls's veil of ignorance, contemporary thought experiments in ethics and metaphysics. Philosophy uses imagination disciplined by reason to explore possibilities. These methods, abstract reasoning, systematic thinking, conceptual analysis, thought experiments, these are the tools of philosophy, and Anaximander pioneered them all. Every philosophy student learning to construct arguments is using methods Anaximander helped establish. Every philosopher building systematic theories is following Anaximander's example. Every thinker using reason to explore abstract questions is walking paths Anaximander first cleared. Now let me bring this all together by talking about our modern understanding of the cosmos, evolution, and scientific methodology. We know so much more than Anaximander did. We have telescopes and microscopes, we have particle accelerators and space probes, we have DNA sequencing and climate models, we have 2,600 years of accumulated knowledge. But all of this knowledge, all of it, rests on foundations that Anaximander helped lay. When cosmologists study the early universe, they're asking Anaximander's question, what is the origin of all things? When biologists study evolution, they're following Anaximander's insight. Life has a history of transformation. When scientists use mathematics to model reality, they're using Anaximander's method. Abstract reasoning can reveal truth. When we seek natural explanations for natural phenomena, we're honoring Anaximander's commitment. The world is comprehensible through reason. We owe Anaximander an immense debt, not because he got everything right, he didn't, not because his specific theories are still accepted, they're not, but because he showed us how to think about these questions. He showed us that human reason can grasp the structure of reality. He showed us that systematic inquiry can reveal truth. He showed us that we don't need gods or myths to explain the world. We can understand it ourselves. And I want to end by emphasizing something we've touched on throughout this lecture. Anaximander's intellectual courage. Think about what it took to propose his ideas in 600 BC. To say Earth floats in space when everyone believed it needed support. That's courage. To propose infinite worlds when everyone believed in one cosmos. That's courage. To seek natural explanations when mythology was the accepted framework. That's courage. To use abstract reasoning when concrete observation was the norm. That's courage. To write in prose when poetry was the established form. That's courage. Anaximander was willing to think the unthinkable, to question the unquestionable, to imagine the unimaginable. He was willing to follow reason wherever it led, even when it led to conclusions that seemed absurd or dangerous. He was willing to propose ideas that would be ridiculed, challenged, rejected, because he believed in the power of rational inquiry. And that courage, that willingness to think boldly, to question deeply, to reason rigorously, that's what we need today. In an age of misinformation and anti-intellectualism, we need Anaximander's commitment to truth. In an age of dogmatism and tribalism, we need Anaximander's openness to questioning. In an age of short-term thinking and superficiality, we need Anaximander's systematic depth. So here's my final assessment of Anaximander's enduring significance. He stands as one of humanity's greatest intellectual pioneers, not because he had all the answers, he didn't, not because his theories are still accepted, they're not, but because he showed us what human reason can achieve. He showed us that we can understand the cosmos through systematic inquiry. He showed us that we can discover truth through observation and reason. He showed us that we can build knowledge that grows over generations. He showed us that we are not at the mercy of incomprehensible forces, but living in a rational universe we can understand. This is Anaximander's gift to humanity. The confidence that we can understand our world. The belief that reason can reveal truth. The vision of a cosmos that is ordered, comprehensible, and beautiful. The courage to question, to explore, to discover. 2,600 years ago, in a prosperous Greek colony on the coast of what's now Turkey, a man named Anaximander looked at the world and asked, what if we could understand this? What if we could explain it through reason rather than myth? What if the fundamental reality is something we can grasp through thought rather than just accept on authority? And in asking those questions, and in following them to their radical conclusions, he helped create the intellectual tradition that has given us science, philosophy, and the modern world. We stand on his shoulders. We think with tools he helped forge. We ask questions he first raised. We follow methods he pioneered. Anaximander deserves to be remembered, celebrated, honored as one of the greatest minds in human history. Not just for what he discovered, but for what he showed us we could discover. Not just for the answers he gave, but for the questions he taught us to ask. Not just for his genius, but for his courage. The courage to think freely, to reason boldly, to imagine greatly. The courage to believe that human beings can understand their world. That's Anaximander's legacy. That's his enduring significance. That's why, 2,600 years later, we're still learning from him. Thank you for taking this journey with me through the life and thought of Anaximander, pioneer of Western philosophy, revolutionary thinker, and one of humanity's greatest intellectual heroes.